Good morning, everyone. Welcome to my presentation. I'm glad you all came in. I know this is a little bit off topic of what we were discussing in here this weekend. Let me introduce myself first. I'm Matyas Prokop. I'm the principal architect in a company called Natilic. We're based in London, offices in Sydney and New York. I have a great job where I'm talking to the clients about the networking, DC, security, wireless, but I'm also talking to the clients about the automation, which I'm really passionate about for last couple of years. And not just last couple of years, I think it's also since I've started using Linux, which was like 15 years ago, when we sort of were doing the automation, but we didn't call it the automation. What we were doing is we started to build the network. At that time, if you remember, it was like a big boom of the community networks in the small towns around the Prague and in the Prague. We started to build the network on Linux. It was mainly wireless, and we obviously were growing. And the way we were growing, it was just immense, and we were still same team, same size of a team. And so there's basically the same issues which the network teams are having nowadays as well. So what we had to do was to automate. 15 years ago, we didn't have obviously all those tools which you have now, like Ansible, like Puppet. We didn't have the processes which you have now, which are usually used by the software developers. And the tools like Git or Jenkins. So all of those topics I would like to touch on today because I think we're like 15 years later now. I think there was a massive development in how we are building the software, and I don't think there hasn't been any big progress in terms of how we are managing and developing the networks, which I think will have to change. Because the way we're managing the network nowadays is basically the same way we were doing it 15 or 20 years ago. And that's a big challenge. I doubt that nowadays, I'm not a software developer, but I doubt that the way we're developing the software nowadays is the same which we were doing it 15 or 20 years ago. By the way, who's the network engineer here? Or who's like configuring network, managing network? Good stuff. I had a call last week with one of our clients because I met him a month ago and we were discussing the automation, and he was like, no, I don't want to do any network automation in my network because that's going to break stuff, or if I'm going to make a mistake, it's going to amplify that mistake across the whole network, which was a fair point. So what I've suggested was to start with a small step. So automate some tasks which are repetitive, which they're doing every day, something like a backups or stuff. So he was like, okay, that's a great idea, let's do it this way. So he called me last week and he said like, Matthias, we're running the network as a code now. So I was like, yeah, that's sort of a true, but not really. Running the network as a code, it's a little bit more tricky than having the Python scripts and automate the way you're backing up your configuration. It's much more complicated. So that's what I will be trying to explain to you today. This title sounds a little bit awful. I don't know what I was doing when I was signing up the title. I think what we can use is running the network as a code. That's what I will be discussing today. And I'm going to show you what does it mean. Because it's not just, as I said, the automation and having a script, but also having the whole process, because this is basically what we're doing nowadays, and it's a big problem in the networking because it doesn't give us, being agile, deploying the configuration quickly, and having this constant development and integration in our networking. So what will be the agenda today? It will be loads of theory at the beginning. We need to be quick. We need to be done with this like in 20 minutes. So I will fly through some topics which I would like to cover before we will go into the demo part. If all the demo gods will be with us, it's going to be smooth demo. I hope it will be the case. So what is the infrastructure as a code? This is what I got from a wiki. Infrastructure as a code is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or static configuration tools. Good stuff. What infrastructure as code is, it's a process. It's something we're trying to learn nowadays. It's something we haven't done for the last few years. And basically what we're trying to achieve is to managing our network the way how the big players like Google and Facebook are managing it. I don't think when sometimes you're hearing the enterprises and the small and medium businesses saying, Google is doing it this way, we're not ready for this. This is how the Google is managing their network. We're different, we're using a CLI. I don't think that's true. I think even if you're a small enterprise and medium enterprise, you can do the way how you can manage your network, you can do it the very same way like Google and Facebook is doing it. So the infrastructure as a code, I think the whole process is very much inspired by the modern software development practices. I think this weekend in here is a great example. I mean, like if you go to loads of the presentation in here this weekend, you're going to see that everyone's are discussing Docker, DevOps, CI/CD pipeline, Git, basically the same tools which we are using if we want to manage the network as a code. I'm not going to tell you, if you're a software developer or at least you slightly touch on the software development, there's not going to be much new for you in this case. The only difference will be the way how I'm going to use all those tools like Git and Ansible. So the reason why we need this is that we are trying to introduce into the networking version control. Nowadays, you have absolutely no version control in your network. You just sign up, or you sign SSH into the network device. You make the change, and that's it. No one can find out, who did this, or can roll back. This is what we're trying to achieve in a network as a code. We're trying to achieve having automatic testing and development. So we're trying to build a process where before you're going to deploy anything into the production, it's going to be tested and validated. So I'm talking about the validation of the syntax, and in terms of the testing, I'm talking about rolling out the change into your staging environment and running the tests. Either it's going to be the manual tests or they're going to be automatic. And obviously the fast deployment. So if you're going to have a process defined, you will avoid all those hurdles which you have nowadays in mainly large enterprises where you have this process which is like, super complicated and no one knows, who done and what someone was tested and what someone didn't test. So if you define that pipeline very narrowly and very specific, you can achieve fast deployment. And as I mentioned, this process is well established. We will be using the same process which you're using in the software development. And that's something which software developers, were tuning for us for the last 10 or 15 years since Git was introduced. And you can obviously put the fancy stickers on your laptop because you're going to be DevOps now. So infrastructure as a code. So these are the main tools which we will be using. Or this is I should say this is a list of the tools which you can use. I will tell you which one we will be using today in particular and which I think are the best fit for the network as a code. So for the change and the source control, I think the best candidates are GitLab, GitHub, and Bitbucket. The reason for that is they have a nice GUI. So for the newcomers into this whole process, it's just easier to using these tools. Obviously, they can use CLI Git if they wish, but that doesn't really make their life easier. At least at the beginning, maybe later on. Automation tools. If you're like a server guy, you probably know already about the Unseeable. You know about the Terraform. You know about the tools like Chef and a Puppet. So again, nothing new. All of these were mainly developed as server tools and how to automate and manage your servers. But in the last couple of years, they started to introduce also the network module. So you can use Ansible to managing your Cisco infrastructure, Juniper. There are some plugins which you can use, which I think it's called Napalm. So you can use the Napalm, which is basically your interface between any sort of device like Juniper, Cisco, and you're managing it through the same and simplify commands. And then we will be using loads of APIs. So the main point of all of this is we're trying to move away from the CLIs, because CLIs, the way you would be managing your device with a CLI is just painful, and not even mentioning automating it. You probably know about the tools which I was using 15 years ago. Expect was just, it was fun. But if you put something into the production, you always get the different message. If you had a different version, you had a different response from the server or from the network device, and then your whole automation was broken. So APIs will give you this consistent response from the device, so you can build your scripts. And APIs, in case of the big players like Cisco and Juniper, APIs are trying to be same at least for 3 or 4 years. They're not making any changes to the APIs, and if they do, usually the old API stays in there for the next 2 years. So you have this consistent environment how to control and getting some sort of telemetry from your devices. Staging or testing environment, this is usually the trickiest one. So in our case, for this demo, I'll be using the staging and testing virtual environment. But obviously, if you're a big company, I would suggest probably to spin up, physical staging environment where you can test it. The reason for that is that I had plenty of issues how to virtualize, for instance, Cisco switches. Cisco switches is really hard to virtualize. You can do it with the Cumulus, you can sort of do it with the Juniper, but most of the enterprises now they're using a Cisco, and virtualizing a Cisco switches, it's really pain. And then obviously the continuous integration and delivery pipeline. This is the most important thing, because when you want to define that process, you will need this. So, I tested, me personally, I know that there is plenty of options, but me personally, I tested the GitLab CI/CD pipeline, which is already integrated. So you don't have to install anything into the GitLab, or you can use the Jenkins. Obviously, Jenkins, is more advanced, it's more established. There's loads of, things you can do with Jenkins. I didn't find it too much relevant for the networking environment, but I'm sure Jenkins is something which I would like to explore later on. So now go through each item. So change in source control. So the reason why we're using a GitLab, as I mentioned already before, is the versioning, but it's also the GitLab should be your single source of truth. The challenge with the networks nowadays is no one knows what is on each device. And you just don't have this holistic picture what's actually configured in your network. GitLab should help you with that, or any sort of Git, or if it's going to be GitHub or it's going to be Bitbucket, you have a single source of truth where you can managing and controlling what is on the devices. Since you have this single source of truth, it's much easier to plan, code, test, and doing that similar stuff which you're doing when you're building a software. Because that's what you want to do, right? You want to test it before you're going to put it into the production. Now, we're not doing it. We're just taking the snippet of the code, copy-paste it through the CLI into the device, and that's it. And we hope it's going to work. So this is why I think the change in the source control is one of the key parts. And the CI/CD pipeline integration, which I will discuss on the other slide, is the essential part of having a change in the source control. The Unseeable. So the reason why I pick Unseeable, I think, because the main reason for the Unseeable, why is it the best solution for the automation, is that it has a strong community. I don't think Puppet or Chef has such a strong community like Ansible, at least in terms of networking. And also the main point is agentless. So you can't really install any Chef or Puppet into the old legacy Cisco devices. You can do it on the newer ones. I know in the DC area, Cisco is planning to integrate the Puppet agent, I think in the next few releases. So it will be possible. But nowadays, at this point, you don't have any chance to install any agent. So that's why you need the Ansible, who is agentless and has plenty of modules which you can use for managing the network. So either it's a module for the ACI, either it's a module for Juniper. Pick one, and these are very decent modules which are always developed. I haven't seen any module which would die out. All of these are very good, documented as well. and lots of REST APIs. So as I mentioned, we will be in a network as a code. We're managing the network, or at least we're trying to. I'm not saying it's possible all the time, but we're trying to use the APIs. APIs is just much more consistent, and APIs should be like a 21st century, the way how we were managing the devices. CLI is something which we should start moving out because even though I understand CLI is good for troubleshooting, CLI is really not good for anything else. I don't think CLI should be used for configuration at all. And then we need a staging environment. So if we would have like a physical environment, it would look actually like this, which we want to avoid. We want to start building the staging environment which will be flexible, and we can change it quickly as we wish, and we can build the staging environment for separate projects. So we will obviously have in our Git plenty of repositories for each project or for the production environment, for our enterprise network, for our DC network. So we would have to have like a staging environment, which will be bloody mess. So what are we going to do about that? We have plenty of options. Hardware staging environment, which is ideal in some cases, but it's not really the best solution in general. We have a virtual staging environment. So I'm not sure how much you're familiar, but we have tools like GNS3, we have a Varela, we have the EVNG, which is a quite new one. I think it's about 2 or 3 years old. It's pretty decent. I test, I'm using it quite often, and I find it slightly better than a GNS3. And then we have a Vagrant. So again, Vagrant, it's a fairly standard tool from the software development. It's nothing new. The way we can use the Vagrant, I'm not going to show it in a demo today because it's slowing down a little bit, the demo. But what we are doing with some clients, we're taking the Vagrant, we're defining templates, and then we're spinning up the Cumulus switches, basically build a spine and leaf infrastructure, test the code, and then just tear it down. And we know that we've tested everything. So Vagrant is a great tool for these purposes. Or we can build the tenants. So today I will be showing you Cisco ACI. It's not because I'm here to selling you Cisco ACI, but it's because I think Cisco ACI is the easiest way how to show you how to build the staging environment without building the large templates and spending too much time on it. The way I'm using the ACI tenant is basically I have a tenant on the production network, which is a great thing. So in my company, we have a Cisco ACI as our production environment for the DC. The way I will be presenting you demo is that I will be basically touching the production, at least the physical hardware, not the production tenant. So I think this is pretty cool, and it gives you lots of options how to testing and staging your environment. And then the CI/CD pipeline. This is the essential part. This is what will be defining the process, and this can either speed up or totally destroy your deployment process and your network. So if you define it correctly, it's a great tool how to make things better. If you don't define it clearly and people start messing around with that, it's a big issue because it can destroy the whole idea of managing the network as a code. So continuous integration, engage. So this is I've tried to build this sort of a slide which is going to explain all those 6 main steps, how to do the network as a code and how the whole process looks. Today, how it looks usually is that you have those regular week cup calls where you're discussing all those changes which you will be making on the network in the next 2 weeks. You're waiting for it for 3 weeks. After 3 weeks, they tell you sometimes on a call like this has been declined for any particular reason, and you just go back home and rebuild the whole documentation, rebuild a whole new change, and you're waiting another two weeks for discussing that change on another cup call. This is not fast deployment. This is very slow deployment, how unfortunately it goes in some of the enterprises. So this whole process will help you out and streamline the whole process. So you can see those multiple steps through which one I will go one by one. And it basically, in a nutshell, it's the peer review. So you will have a centralized peer review. So everyone will have the access to that particular change and comment on it or can ask for a commit into the production. they can, automatically it will be deployed in a staging environment, and then it's going to be peer reviewed again before it will go into the production. So you can see peer review is usually, you're starting with a git push. So you push the configuration change into the repository. It will immediately pop up in a git that the change has been made, and somebody has to review it. It's going to be either your manager or some of your leads in the team, or actually some of your, your peers in the team who can give you some sort of feedback on a change and say like, okay, this is good, this can go ahead. So if the team agree on that, it goes into the development repo. So the way then what I usually suggest is to automate this process. So when it has been peer reviewed from your colleagues, it goes into the staging environment, and in that staging environment, it deploys. In our case, it's going to be ACI tenant called staging, and in that staging tenant, which is completely separate logically from any production, you can do your test. They can be either automated, you can use many tools. I think there is this great tool called PyPTS or something like that. You can use robots, which are, for instance, can check if you made a changes into the BGP, or if you made a change into the OSPF. They can change. They can check all the peers if they're up, and also check the routing table if you're seeing any sort of changes in the routing table. So you can do all this stuff in the staging, and if you think that everything is okay, you can basically create the merge request. And the merge request is the same merge request which you're sending on a GitHub if you make any change to the software. So that goes into the deployment checks. So that's that cup call, which it's not really necessary anymore, because you have this merge request which can, 5 other guys from the board or whatever can review it and say, okay, this is good to go, this has been tested. The robots in the staging check all the BGP, so none of our clients will be affected, and this is good to go. So they just close the merge request and say like, okay, merge it into the production. So what it does is basically move it from your development branch into the production branch. And we have time for the live demo. So fingers crossed, it's going to work out. I'm going to show you, what our live demo will look. So on the left side, you can see there is our ACI deployment in our DC. This is the production. Physically, it looks sort of like this. You don't have to be worried. I'm not going to be teaching you here about how the spinal leaf works and blah blah blah. We have a GitLab and we have the Ansible in our demo. I don't want to spend too much time on explaining ACI, but I think this is quite important to explain to you. So on the left side, we have our production tenant. You can ignore it. What I'm trying to show you is that we have those 3 separate tenants on a single physical hardware. So the left side, you can ignore it. We won't be touching it. And if I would touch it, our admin would probably kill me. But where we will be making the changes is the Natilik showcase and Natilik showcase staging. So as you can see in the staging, we will be deploying the changes before we're going to be deploying them in a Natilik showcase. The tenant Natilik showcase is quite important for us because that's where we are showing to our clients all the changes. That's why we introduced the Git, because what happened to us, we were like a typical enterprise. I left the office on Friday evening, and on Monday morning, I had a meeting with a client where we were discussing some stuff on the ACI, and I need to showcase him something, for instance, integration with F5. And I came back on Monday morning, ready for the showcase, and suddenly I found out that nothing is working because somebody was playing with it over the weekend and preparing for his demo. So that was one of the main drivers why we introduced this in our showcase. So that's why we have a staging, that's why we have a Natilik showcase tenant, that's why we're going through this whole peer review if we want to make any change, because I am the owner of the showcase, and I want to make sure that everyone from my team, if the client is coming in, they will be ready, and the client will be happy when they will be leaving the meeting. So here, I'm going to click on the tenants. So the tenants will show you what all tenants we have in here. This is in the ACI, so you can see we have the Natilik showcase and Natilik staging. it's all clear. So you have a 0 bridge domain, 0 VRFs, 0 EPGs. So this is the APIC, and this is our GitLab, which we will be using. I will zoom in a little bit as well. So as you can see, we have our CICE ACI repository, and it has 2 branches. Well, it has 4 because some of you guys are working over the weekend on implementing some changes into our showcase. But basically, we have two main branches. One is development and one is production. When we are making change, we're pushing it first into the development branch, where which basically is assigned to the staging NetDevOps showcase tenant. So any of those changes which are in a development branch are not replicated into the production. They're going into the staging. After you're going to move all those changes from the development into the production, they are pushed into the showcase branch. So when I've mentioned all that stuff about the YAML files, this is basically how it looks. We're managing, our network through these YAML files, where we're all defining only the attributes of the objects. So ACI, imagine ACI as the collection of the objects. You don't configure anything for the CLI. You're defining everything for the objects. So what we're having in here is we're having the bridge domain, which is like 2 objects, and then we are having the EPGs, which are endpoint groups. Imagine endpoint groups as a group of servers who are allowed to talk to each other only within the endpoint group, but not between the endpoint groups. Between the endpoint groups, you have to define the rules, and that's the whole point of the Cisco ACI, where you need to basically define who can talk to each other. But I'm not going into this one. What I'm trying to show you is in here we have all those objects defined. So what I will do is, since I showed you that we have the APIC clear and the NetDevOps showcase and NetDevOps showcase staging, you can see there is 0 objects. So what I will do now is I will just simply push the change into the Git repository. So I've defined all those objects. Now I will define the comment. What did I did? What will be the content of the commit? So you can see 1 file change, 7 deletions, because I've made at least 1 change. So I will be able to push it into the Git, and then I will just push it, and that's where basically it's kicking off the whole process of the pipeline which we were discussing. So I go back into the Git, and I will go into my pipeline. And as you can see, it's already doing something. So these stages, good, you can see it. So in the stages, in here we have 2 stages which are defined. So what we can see in here, the validated staging. What it basically did is it checked the syntax of the YAML files. Nothing really fancy. The reason why I'm doing it is I want to avoid that if I'm going to be starting to pushing it into the development environment, into our staging, I want to avoid that it will just break the stuff or Ansible will give me some error, because that's wasted time. So first thing I want is it go through all YAML files in our repository, and it will check if the syntax is fine. So in here you can see, there's a few warnings, but nothing really major. What it also did, it sent me the Spark message. So in my Spark, I'm basically seeing this is some sort of like a Slack. In a Spark, I'm seeing status update and staging. So we're good in here, and I can also see there's a tick box, green light, so that's good. And since this was successful, it goes into the next step, which is pushing it into the staging environment. So in here, you can see all those objects which has been pushed by the Unseeable. So this is Unseeable pushing the objects into the ACI. So if I will look now into the ACI, I should see the new objects here in staging. So I'll refresh that. And you can see there are two new bridge domains, one VRF and one EPG. What I can do then, I don't want to go too much into detail into the ACI in here, but basically I can check, if everything has been defined clearly, if I have any servers defined to those endpoint groups, I can test the connectivity in between, or if there has been any changes into the BGP in a fabric, I can check the BGP sessions as well. So, and that can be all automated if you want to. I don't have it automated in this case, but we have a client who does that. So we're good in here. So let's say that we've done all the tests. Everything seems good. So now we're ready to push this into the production. So I am the owner of this repository. So you can see push to development and Matyas showcased ACI 3 minutes ago. So what I will do, I'll create the merge request. And again, that's nothing new. If you're doing the software development, we're basically doing what these guys who are developing software are doing already. So we're moving it from the development into the production branch. So I'm happy, source branch development, target branch production, submit merge request. And this is how we created the merge request. So I was the developer. At this case, I'm not separating that role of being a developer and of being a master of the repository. So it's not that obvious, but until now, me as a developer, I was able to do it. However, now it's only time for the owner of the repository to step in and say, okay, you want to merge something from the development into the production. May I have a look? What are you actually suggesting? So I can click on that change, which was define new staging environment. If you remember, that's what I was put into the comment when I was pushing that change, and I can see what change I've made. So before that, I have this nginx object defined. I removed it, so I can even see what I've made. So if I broke something, I can immediately blame that person who did it, because I can see, that somebody removed it, and I know exactly who was it and when was it. Or before blaming somebody, I can actually roll back immediately. So I'm saying okay, this is good. So I'm ready to merge it into the production. So I'm clicking as the owner of that repository. I'm clicking on a merge. And merged by Matyas less than a minute ago. So I will go again into the CI/CD pipeline and see what's going to happen. So I have already one green light in here. Validate the production. It basically did the similar stuff. I think I've added one more check about pushing it into my backup repository as well. But otherwise, it do pretty much the same. It checked the syntax again if everything is ready for the push. And it sends me the Spark message into my space. So the last step in here is, and it's the manual one. You can see it hasn't been automated, but me as the owner, I'm responsible to say, okay, I'm ready for it. This has been tested. I'm happy to go, and I'm going to push it into the production. So if I go in here into the all tenants, you can still see the Natilic showcase. It's still empty. We don't have any objects in here. So when I will click in here and I will play this task, and I will have a look, you can see it's starting to gathering the facts and pushing it. So job succeeded. All the objects, it looks good. It has been created. I can even see in here status update production, submitted by me, pipeline number. So I can have a look, who deployed what. And now if I will refresh in here, I can see it, the object has been created. And basically we can see that it's complete replica of the staging environment. So what we achieved was exactly that pipeline which I was explaining at the beginning. You have clear steps which we went through. It has been reviewed, it has been tested, it has been staged, And now we're in a production in a very short amount of time, but we have a clear visibility, who did what. So in case that something went really wrong, even though we've tested it, we can roll it back, or we can actually find who made that change and start blaming for breaking the stuff. I mean, this is something which enterprises are starting to understand. It's quite new for them. It's completely new environment and new tools which they have to learn. But I'm seeing at least in for instance in the UK or in France, there's a more and more companies who are starting to adapting it. So I think we're sort of on a brink of enterprises starting to embracing this stuff. And we're already seeing, loads of enthusiastic people, for instance, in London, where we are doing some meetups around the Ansible and the automation. More and more network engineers are starting to understand that the clear benefits this brings. And that's pretty much it. This is my contact. If you want to stay in touch, I'm on Twitter. I have my Git. These are my emails, like a private one. I didn't put any company email in there. And happy to catch up with you guys. Thank you.